I again lost a few motor drives while building version 1 of my printer. So now I have to work up my courage to continue the build. In the meantime, I couldn't help myself but think about what the next version of the machine might look like. Why a next version, you might ask? Mainly because version 1 is too mechanically complex. And because I like to think about motion systems. And I think I found a good one for version 2. Let me show you a first prototype. The aim of the motion system is for the printhead to be able to reach every point of the build plate. This requires two axes, in this case one on the left and one on the right. The left one is a very simple linear stage. On top of it, a rotary axis is mounted, which is then driven by the second axis on the right. So the right axis rotates the build plate, and when both axes move together, the build plate moves linearly. Driving the system is a bit more involved than for a Cartesian printer, but with a bit of maths and a bit of trial and error, we can, for example, draw a nice little square. So the motion system works, which is all nice and good, but why should it be better than version 1? Mostly because of weight to stiffness ratio. The axis should weigh well below 100 grams, which is less than half the weight of version 1. Despite this, it should be just as stiff. Then there's simplicity. With version 1, the belt paths are very complex, and this to some extent holds true to all CoreXY motion systems. In our case, there's only 2 straight belt loops. If one had the budget for it, one could also just use linear direct drive motors and arrive at the beltless design. Despite its strength, version 2 also comes with its own set of issues, the first one being backlash, which is the play between 2 gears and cannot be avoided. However, I'm thinking about using a capstan drive instead. This would remove backlash and is lighter, but also introduces more elasticity. The second issue is the compute needed to calculate the motion paths. But as long as this can be done on a computer, it should be fine. Lastly, for the motion system to be accurate, homing has to be very precise. A small change between supposed and actual position can significantly deform the print. All in all, however, I think the potential of this motion system outweighs its challenges. So, stay tuned for the next iteration.